Hello everybody, this is Sachin Hulagiri. Let's continue our discussion on statistics and data science. Volume number 5, Measures of Position and Dispersion. In this chapter volume, we are going to cover on measure of position like median, quartile, decile and percentile. Measure of dispersion, range, quartile deviation, mean deviation, standard deviation and variance, skewness, moments and kurtosis. All this comes under the descriptive statistics. Okay, let's see the measure of position. Measures which divide a given data into equal parts are known as a partition values. Means measures basically divides the whole data into equal number of partitions. There are certain 4 types of partition values: median, quartiles, deciles and percentiles. Let's see one by one. What is median? Median is a measure which divides the data into 2 equal parts. Here we sort the data in order and identify the middlemost value, that is called a median. Means median divides the data into 2 equal parts. And next one is quartiles. Measures which divide the data into 4 equal parts, quartiles. And there are 3 quartiles which divide the data into 4 equal parts. 3 quartiles are like denoted by Q1, Q2, Q3. First quartile is known as a Q1, which divides the data into ratio 1:3. Means the first quartile covers 25% of the data. And quartile 2, which is known as the second quartile, it's also denoted by Q2, which divides the data into 2 equal parts, means 50-50, 1:1 ratio. Median and second quartile are both same, which divides the data into 2 equal parts. And a third quartile is denoted by Q3 and divides the data into ratio 3:1, means 75% and 25% of data, and which can be diagrammatically represented as like this. And note, we need to remember that there is no concept of a fourth quartile, as a fourth quartile itself is 100% of the data. There is no such concept called fourth quartile. In the same way how the quartile divides the whole data into 4 different parts, and the same way we will have a deciles. As the name suggests, deciles, divides the whole data into 10 subspaces, 10 equal parts. Here it is D1 represents 10% of data and D2 represents 20% of data, like this so on, and D9 represents 90% of the data. Means when I say D9 data, my data is having D9 means comes under my D9, means it is 90% of data is covered here. Note, we need to remember again here the same like a quartile concept. There is no concept of a 10th decile, because 10th decile itself is 100% data. It represents full data. And a percentile, as the name suggests, percentage or percentile. The percentile is a measure which divides the data into 100 equal parts, are called a percentile. And here, as the name suggests, there are like 99 percentile of data denoted by P1 to P99. And we need to remember P25 is nothing but a quartile 1, which is 25% of the data, and P50 is a quartile second quartile, which is Q2 and is also known as a median, and P3 is a 75% of the quartile, it's a third quartile, it's known as a Q3. And here is the same like other things. There is no concept of 100%. 100% is considered as a full data itself. Okay, let's continue. Measures of dispersion. The study of a scatter or a variation of values in a data from any measure of central tendency is called a dispersion. Means when we plot a data in a graphical way, we will identify the centralmost value, which is like a central tendency, which is called a central tendency. From that, how much data is dispersed, that study itself is known as a dispersion study. That is, there are different kind of measures we use for dispersion study. One is like a range. In the range, it is difference between the highest and lowest value of the given data. It's nothing but a range of between two datas. And another one is quartile deviation. Quartile deviation is defined as a half of the interquartile range, which means the data lying between the Q3 minus Q1 divided by 2. That is a deviation which is from the central tendency, that is called a quartile deviation. When you call it as a mean deviation, it is a mean of the absolute deviations of a set of observations from any measure of central tendency. Means it is an absolute deviation from the mean, and it is calculated by using a summation of x minus mean and divided by number of n, which is n is nothing but a number of observations. And we need to remember, it is recommended to calculate a mean deviation from median as a mean deviation minimum always is a minimum. Means like when it is compared to the mean deviation from the mean and mean deviation from the mode. This z is nothing but a mode, because it's a middlemost value, which is the most trusted value in this mean deviation calculation. Median. Standard deviation. Standard deviation is a positive square root of a mean of deviations of the square deviations of a given observation from their arithmetic mean. It is denoted by sigma. The formula for this one, square root of summation of x is a observed value minus x bar is a mean value, mean of the observations, divided by n number of observations. And the variance. Variance is the average of a square of deviations of a square values taken from the mean. By taking a square of deviation, it is better technique to get rid of a negative values, since we want to represent the variance in the data variance in the form of positive value. So we will take a square of this standard deviation. It is nothing but a square of standard deviation represented by sigma square. Let's see. When we plot a data, and we will see we'll get some bell-shaped curve, and the bell-shaped curve may be different curves, different shape again, and we will see that interpret based on the using skewness. So skewness means the lack of symmetry in the given distribution. In other words, if the distribution is asymmetrical, then it is termed as a skewness. Means if data is not symmetric on both the sides, then it is called data has some skewness is there. Let's see what is symmetric distribution. When we call it a symmetric distribution, here the mean, median, mode are equal. They all lies on a same point, mean, median and mode. When the values of a mean and median mode are plotted on the graph, we will get a bell-shaped curve. In other words, there is no skewness. Means it is a symmetric curve. A typical symmetric curve looks like this, where mean, median and mode are lying at exactly this point. Asymmetric distribution means the mean, median, mode are not equal. Distribution looks like a skewed bell-shaped, means dented bell-shaped. Let's see how it looks. There is a positively skewed, means the mode is have a lesser value, and a median is a bit more than that. Mean is the highest value in the positively skewed data. Means here the mean will have a greater value than the mode, and the median always it comes in the middlemost value, as name suggests. And negatively skewed means here the mean will be a lesser value and mode will be a greater value. And again, in the same way, median comes in the middlemost. Here if you see mean is like it will have a lesser value. Here it comes a negative values, here it comes a positive values, so we'll call it as a lesser value. Mode will be a bigger values. So the moments, okay, moments used to calculate the deviation taken from the mean, an arbitrary point of a distribution or an arbitrary point of distribution, means how the data moment is. The moments are popularly used to describe the various characteristics of frequency of distribution, such as the average, dispersion, or a skewness and kurtosis. Based on the moments order, we'll define the skewness and kurtosis. The different types of moments are there, which are like with respect to central moments. And a zero order moment is nothing but it's a mean. About a mean is 0, means it is a absolute mean value, exact mean value. And mean is a first, there is no moment. Zero order means there is no moment in the data. Mean is a first order moment, means the mean r is equal to 1. The formula will be like this: mu1 is nothing but a summation of x minus x bar, which is mean, and power to the power 1 and divided by n. This is a mean. And a variance we can calculate using the second order moment, means variance will be calculated with the power 2, mu2. And skewness is a third order moment about the mean, means from the mean is skewness, which is r3. This defines the skewness. And the kurtosis is a third order moment, it's a fourth order moment, and about the mean is kurtosis is r4. And this is a mu4, and which is raised to power 4. This will be like, these are like different moments where we can calculate from the, if we know mean value and the observed values. So when we call it as a kurtosis, okay, for given kurtosis gives a measure of flatness of distribution. As we see, either the data is symmetric or non-symmetric, which is positively skewed or negatively skewed in the previous concept. And there is one more concept called kurtosis. Here what we'll do, how the data is distributed with respect to flatness, whether it is more flat or less flat, or it's a perfect normal distribution. So degree of kurtosis distribution is measured by the relative to the normal curve, as I said, normal curve. And a leptokurtic, it's a thin, as a leptokurtics, the curve with a greater pickedness than normal curve is called a leptokurtic. Means it looks like as lepto, as L. Lepto means it's lengthy, it's L shaped, means it is bigger, it's more height than the normal curve. And a mesokurtic is a middlemost value, represents the normal curve. This black color, this is a mesokurtic, which is a most appropriate normal distributed curve. And the platokurtic is a, it looks like as name suggests, plateau, and the flat, the curve which is more flat than the normal curve, means here data is more flat than the normal curve. And we can also measure the kurtosis based on the formula. If we know mean and observations, we can define the calculate the kurtosis. The measure of kurtosis frequency of distribution is based on the denoted by beta 2, which is given by the formula mu4 divided by square of mu2. If beta 2 is 3, the distribution is said to be a normal and the curve is a mesokurtic. This is the middle one. If it is beta 3, if it is more than beta 3, which is distribution is said to be more peaked and the curve is a leptokurtic. This will be a beta 2 greater than 3. And if the beta 2 is lesser than 3, the distribution is said to be flat or a flat topped or a curve platokurtic. This is a red curve. This completes the moments and the distributions. Thank you very much.